This active heat recovery and ventilation system helps to keep your indoor air fresh and healthy, but not with the outside temperature. In other words, fresh but not cold. Well, that's good news for winter. But in the summer, this system will also do an excellent job. It will cool the warm outside air. That is replacing the inside still air, while outside there might be a heat wave. So this do-it-yourself system is for the whole year. In this video, you will also see how I make a 10 centimeter diameter hole through the whole wall. This is necessary for the ventilation. Hello dear do-it-yourself innovators. I'm Norbert, energy engineer, and ready to continue the idea of video number 85 about an air exchange system with active heat recovery. Maybe it's better to watch that video first. You'll find it in a dedicated playlist, and it explains why it is so useful and how it works. I just want to compare this in a few phases with a passive heat recovery ventilation, which is already so good. There you have the incoming air that is still pretty cold in winter, let's say 5 degrees Celsius below the inside temperature. But with this system, the incoming fresh air might be even at 35 or 40 degrees Celsius. So it is actually contributing to the general heating in the house because of its high efficiency caused by the optimal temperature at the evaporator. That's this cold spiral. You are heating the room at the minimal cost, and it needs only 150 watts for the compressor, so you can use it simultaneously with the other electric consumers in the house without blowing the home fuse. And then the hot part of this heat pump, that is this spiral, that might give you even 600 watts of heat because of this high efficiency, the high COP, coefficient of performance. And even if that is not enough for the whole room where it is really cold, with moderate cold outside, it might be enough. And surely you can switch off the central heating for quite a number of days in the year, in the spring, now, and afterwards in the autumn, and in between in the summer. It will contribute to the cooling just by turning the fans around. In this video, I will show you the preparations. That's to make a big hole, cylindrical of 10 centimeter diameter, in the wall with a special drill core that I bought for less than 30 euros. So here's a drill core, and here's a piece of wall which is made by this drill hole. There you are. It's the first time for me that I used it, so that's already an interesting thing to see in this video. Well, I have more experience with dismantling small heat pumps. Just to show you a little bit the inside, the fan, the user interface, and a few neurons of this device. And that is really the basis. You should get this experience. So I thought to dedicate a good part of this video to this basic skill. You will see it in a few minutes. That will enable you to recycle more than just one of those second-hand devices, which are so cheap and still might become the basis of your cooling and heating technology at home. You will have the best for a few dollars. It is really a form of capital creation, adding value to your home, which is asset number one for most of us normal folks. Your friends will be amazed and will ask you to install it also for them. I want also to show how to approach this technology in a pretty scientific manner, using an affordable anemometer, a wind speed meter. You see it here, and there's also a link in the description, to determine the amount of airflow in, for example, such a device, which is very silent. With this fan itself, if it's convenient, I don't think because, well, it is bigger than the hole which I will make in the wall. But for example, these kind of fans, they are the right measure for the hole which I will make. And I measured, with this anemometer the airflow of this fan, and the speed was more or less 1.4 meters, if I remember well. And if you compare, if you calculate then, if that would be the uniform speed of on a 10 centimeter diameter airflow area, so that would be the area of the hole in the wall, then you have per second you have about 14 liters of air which is going through that hole. And of course you have also to correct for the airflow, because close to the walls of this tube which will go through the hole in the wall, there will be less airspeed, so you have to correct, and maybe it will be 9 liters per second. Anyway, if you compare, if you multiply that then with seconds in an hour, then you get more or less, yes, than 35 cubic meters per hour. But then you don't have calculated the resistance of the evaporator and the condenser, because the air must go through those metal grills, and that will then be a little bit less, let's say maybe 20 cubic meters per hour, just with this fan. Well, we have to measure that, because if that doesn't go well, then we have to use the restroom fans, those fans which you see always in the restroom, and which is switched on together with the light. Those are much stronger. And if you have 2 of those fans, one for the evaporator and one for the condenser, you can put them in series, so that in Europe, with our 230 volts, they get both 110 volts, and then they will still work, and they will be very silent, and then you can just see how much air you will have, how much airflow, considering also that this air must go through both these structures. So this the warm heat exchanger, and this is the cold heat exchanger. And then you can decide which you take, or you take this fan, or you take this one. I bought also a good, but not very expensive oscilloscope to show how the compressor is able to create a rotating magnetic field so that it can let spin the rotor. In a way, it is like the V-engine of my Moto Morini, which combines 2 simple one-dimension oscillating movements orthogonal to each other in a circular force. And so much has changed in the functionality and also the price of those wonderful measuring instruments. How could an electric engineer like me do so many years without it? So we have this dehumidifier that has a cold and a warm heat exchanger. The outgoing stale and warm air gives its heat to the incoming fresh air. We are still talking about the winter. A process that will run at a very high efficiency because of the good thermal conditions, especially at the cold side of the heat pump, the evaporator. Each hole in the wall corresponds to one of the 2 heat exchangers, and each hole has a fan of about 20 to 40 cubic meters per hour. The air exchange should be enough for a room of about 20 square meters, so for example 4 by 5 meters. And that will give you 1 air exchange every 3 hours. Imagine what health effect it will have on you and your family. You can apply it in every room where there are many people around and where they stay a lot of time. That's maybe only 2 rooms, the living room and the bedroom. Yeah, okay, 4 holes, I hear you think, and at least you have a reason to drill them for themselves instead of paying another to do it. The second-hand dehumidifier must be dismantled and appended on the outside of the wall, just in front of those two holes in the wall. Dehumidifiers are available on the second-hand market in great numbers because the winter is nearly over. And you will have your system working, in the last cold days of the spring, but also before the first heat wave is coming. And then you are prepared for the next winter just by turning around two fans. I'll show you now how to dismantle such a dehumidifier and show you also the flow scheme of the air. Take this out. Then you see here two screws. No. And wire diagram. We see here the refrigerant R134A. This here. So, other side. So now it's all open from all the sides. You saw already this part with the compressor, the capacitor, the fan, the user interface. And here you see the dehumidifying part. And the air is coming here into the device, and what he will first meet is the cold. This is the cold side, and when it meets the cold metal part, humidity will condense here on this place, on this metal, and it will drip down. And it will come out here, and then it will go here into this part, in this container here. So it goes directly from here, it dips here down in this tray, and then it dips down here. And then you ask, okay, but heat pump, of course you know it is a heat pump here. And the heat pump has also a warm part. And this warm part is here at the front side. Let's see if we can find it here. Yeah, you see it a little bit better. Here's the cold side, and here you see separation, and this is the warm side. And what's the warm side here doing? Well, it's just heating the air which is coming cold from this. So the warm part is immediately connected to the cold part. So the cold part does its work by drying the air, because the water will drip down here. But then you have cold air, and you don't want to have cold air in your room. So then the same air goes to this front part and is heated up again. And then it comes here through this fan at a slightly higher temperature, because you have of course also the loss, the heat from this compressor that is also going into this heat pump, and that means that the heat, the hot spiral, gets a little bit more energy than this takes away. And here you have still a sensor, and it is coupled to the cold part, and that is controlling the temperature. Maybe it will see that if it's too cold, it wants to avoid that it's freezing and that it's all closed by ice, and then it will stop working. With this object, this dehumidifier, it is important to do everyone's tests when you are dismantling it in a way that if there is something that it's not working anymore, you know where the fault is. Okay, I don't want all this stuff, all this electronic stuff. I want to really have control myself, because otherwise it stops when you don't expect it, and it is a lot of complexity and also volume which you have to handle. So I said I want just the compressor and this circuit. I want to take away all the stuff, and then you make a kind of a short circuit. So you go right to the technology which you are interested in. And that means the compressor and the capacitor is here. That's the capacitor which helps to make a turning electric field, so that the rotor will follow this spinning magnetic field. So that is a phase shifter. So if you have only one pole, one sinus power supply, then you have a magnetic field which goes in this way. And the same is true also for the car engine. You have also the cylinders which go in this way. The AC supply, that is just plus minus plus minus, and you must make that a turning field. And the phase shifter, the capacitor, does that job. So in some way you must understand how this is connected, the capacitor to the compressor, and how that is connected to this power cable. And that is what we will do now. Everything away and let it function with only the compressor and the capacitor. That's the best way. Now we start with making this system with the compressor and the two heat exchangers completely independent. So you have this compressor, you have the capacitor, and these two heat exchangers, which together form the electric and the refrigerant circuit, and that's all you need. So let's take away this cap where the contacts to the compressors are. You have here a spring, and there we go. Those are the contacts. May I show you the overload protector? So here is the overload protector. It is a temperature sensor. It is onto the compressor, and if the compressor is too hot, then this will just switch off, and that will mean it will get no current anymore. Here we have the contacts of the capacitor. They have of course always two contacts only, but this is going to two places. In order to follow the connections between the capacitor and the compressor, we just follow the wires. So Needless to say, components, for example this switch, it's always useful to have them, and you put them in some box so that you expand your parts collection. I see here two contacts. They have always two contacts, but here you have a double contact for one pole, and we will just see how this is connected to the compressor so that we know how these can stay together in the new configuration. Okay, we follow this, and this goes to this cable, to this combined cable. This blue one, and it goes to here. And then there's a red one that goes to here. And this of course the overload switch, and it goes to here. So practically this red wire, this red cable, goes to here. And then you have still this white cable, and that goes to this contact. So this white cable goes from the compressor to here. So that means that the capacitor is connected between these two contacts. So this is the phase shifted contact. The compressor itself, so without this overload protection, has only 3 contacts. And that is because it has 2 windings, and one contact is shared between the 2 windings. So this is the shared contact, because this blue cable of the capacitor goes to here. And you know that this capacitor has one pole which is for himself. This can be only the shared contact, because this goes also to this. This here is also a winding, so here is one winding and here is one winding. And this is the start winding, and this is the running winding. And you can also check that with the ohm meter. Okay, before we make this resistance measurement, I just want to see the state of the capacitor, which could still be on a dangerous voltage. So I put it on direct current, and I put the high voltage, and then I will go just between the contacts. So that means we have really nothing to fear from this condenser, and that means we can also safely make a resistance measurement of the windings. So this 0 ohm. $59.60 ohm. That's the capacitor circuit, the start circuit. And now we have this. That's 25. Yeah, that means that's more or less the half, and that means that the big power is of course going through these windings, and so that is just a confirmation that this is the run winding of 26 ohm, and this is 60 ohm, and that is twice the resistance, and that means that's a thinner wire, and that is the start winding. So then we can go on. We can leave this in place. That is useful, this overload protection. And well, we will just take the circuits of this capacitor and this compressor, and we know now how to connect it, because at the end of the day we need only 3 contacts, and that's of course this ground wire, and then the 2 wires to the grid voltage. Let's now go from the start, just from the power cable, and then you see that there are 2 colors. Of course there's the ground cable, but the blue cable, that would be the neutral, and it's going from the power cable to this contact here. And then from this contact there's another blue cable which goes to this capacitor. And from this capacitor we are going also to the compressor. And then we arrive here. So this would be the common. And the other cable of the power is here. That's the brown. But then here is a bit of switch work, and then this brown becomes red. And from the red it goes to this overload protection switch. And from here it goes here. So this is the real power, the running winding. What I find a little bit puzzling is that here is the C and here is the R from running, one would think, and here is so this would be common, run, and here's the S, you see written here, of start. So the white would be the S, and I would say that is the start. But from the other side we see here that this neutral color of blue, it goes here. And here's coming the power, the red wire, and black, it becomes black and it's here. And then this must be the common, so the white is common. And if we make a resistance measurement, then we see indeed that the capacitor is connected between white and blue, as you see here. And then we have a resistance of 34. Now this running, this because it's the red and the black, that is from the power connection, so that is the main winding, and that is indeed the half of the resistance of this one, which are of the capacitor. So this 60 ohm, so this is the capacitor, blue and white is the capacitor. So that means the white is the common, and this is the start winding, the blue is start winding, and then this is the power winding. And that makes sense, because in this way we have here we have the live connection to this whole combination of capacitor and compressor, and here the blue is then the neutral, and then we have the ground. And this is just a connection between the capacitor and the compressor, so that doesn't go outside. So that means we connect to the power, to the mains power, these 3 wires. 1, 2, 3. So we can just cut it, and of course not this one, but this one. These are the connections which we will use. And then we have no switch work. We will go right from the main grid. We will go to this configuration which we want to keep. Now, okay, this ground wire, okay, it is connected now, and if we keep this on this ground here, on this base here, then we can keep it. But this one has to be cut, and it must be connected to this wire. So here. And this blue wire, which comes from a power supply, must be cut, and then it will go to this, because this is going to the capacitor. So it means we cut these 2. And we cut also these 2. And then we will use just this kind of clamps, the contacts, to connect them. Only these 2. So we have 4 wires, and if we use 2 of those units here, then we have if we use 2 of these units, then we have 4 contacts. So that's correct. So there we go. So that's the dehumidifier. And here we have the power cable, the power supply. And as I said before, for the sake of recycling, you have here this small little cable, and you have this contacts, and that can be useful to for the next time if you want to connect some device which has this kind of contacts, like this or this. And there are plenty of them. As I said, also this switch, they have all these kind of contacts. And then we want to take away the insulation. This is very low power, it's just half an ampere or so running through this. And we can take all this away. No, not all, because we have here still a sensor, temperature sensor. So that's the temperature sensor. And now this, the fan and the control unit. And also this user interface, we can take it away and use it for some other thing. Also this fan, maybe we will use it if that other computer fan is not strong enough, we can always use it. But okay, this is the power cable. And we connect it. We put it on this contact. See? See? So you heard it? It's dog walking time. It works and it is quite quiet. Purchase the drill core. And then I hope that you have a drill machine with enough power. I think that 500 watt is enough. This one is 600 watt. I will put a link in the description. There are drill cores for normal and for SDS machines. So SDS means that you have these sleeves which go into the machine. Take care not to hit electric or other ducts which might run through the wall. Make the hole without the percussion function. At least that seems to be the norm for brick walls. Let it turn about 5 turns per second and don't push too hard. The drill motor will become warm also without pushing hard. Even I felt warm afterwards and I had to take a shower. But I didn't take the drill machine with me. It doesn't like that. And then regularly take out the material from the drill core and also out of the tunnel. Buy a piece of tube of 10 centimeters outside diameter, divide it in two and put them in the two holes so that you have a clean and airtight duct through the wall. This is the first time that I use this kind of drills to make a hole of 10 centimeters diameter in the wall. I do a lot of new things since I am doing this, running this channel. So we must go on, even if I feel a little bit uncomfortable with this new job, with this new task. So let's go. And of course we think also about safety. So I suppose you understand that this drill, this normal drill point, is for centering, so that it really goes. It doesn't jump all around over the wall. I think I will just do it with only the point. I take away this drill core. And we go back to the normal position without percussion. Oh, it's very neat. Do you want to see it? So there it is. This was the wall. And this is the back side. And look at that. It's just as if there's some piece of wool just finished, because I cut only here at the walls, but not here, this side, not the back side. In some way it's very even. So I think it's just that we arrived here at some other point, another layer. It lost the bolt here that keeps the central drill. There's also a piece with this piece here, which is special for eating away the stone. And then you have to put it on the hammer. So you go here. It's now on just turning. And then this is turning with percussion. And now you turn it to only the hammer. You see this central piece, I just have to break it away, because there's already a nice groove around this central piece, and I think it's just hindering. So I will break it away with this tool, which is on the same drill machine. No. Wow, that's good. Actually, I can do a lot with this device. It's also quick enough. Yeah, that goes. Okay. In other words, you have to remove this first. So there it is. I did some brake work and now I'm through. So just a combination with the turning part and the drill part, and you have this result. So I will now finish with the turning part, with the drill core. So there it is. And we will cover this up with the box so that nobody will see it. Anyway, it will be beautiful. So it has really to go inside. You can always close it with a bottle if the cold wind is going inside. The box for the compressor and the capacitor, so the electric part, will be the subject of the next video about this project. So I don't know if it will be the next week, because you may know that I am multitasking between several projects, also given by the time that I have to study it, that I have to find the pieces, etc. I have already an idea to make this box watertight against the rain and also simple to install at the outside of the wall. It will also be simple to open, for example, to clean the filters, so I didn't talk about them yet, and turn the fans at each change of season. I hope you liked this video. Please subscribe and hit the like button. I would like you also very much to share it with your friends. I think healthy and fresh air is very important for everyone. Bad air will let you suffer without you knowing it. Okay, stay healthy and I'll see you next week. I would also like to inform you that I have another channel. This channel is for you, do-it-yourself and homeowner or renter, anyway in the domestic sector. But I have also a channel for organizations, and it is about the greenhouse gas accounting. That's very important for the climate change. It is for reducing the emissions. So I treat projects, ways and strategies to reduce the emissions of organizations. They can be factories, they can be service sector, they can also be local governments. And I can also imagine that you are not only a homeowner, but maybe you are also in such an organization which has a lot of emissions, and maybe you can take a look at that channel. And well, then I hope that you will learn a lot and that I can contribute also in that way to a better climate. And thank you very much for sharing this.